Hey guys, it's Mr. Wood from my house again, and want to tell you guys I'm missing you guys. This is not the way I like to do it, but it is the way it is, so we're just going to do the best we can, and a lot of help with my wife here, and I'm going to kind of pick up where we left off. I want to talk again. I sent you guys an email today a little bit about the AP test and what's going on with that, but by far and away the most important thing, of course, are jokes. So here we go. I know you've been missing jokes. Why wouldn't they let the butterfly into the dance? Because it was a mothball. Get that, mothball? Okay, and here's the other one. What did the tornado say to the car? You want to go for a spin? Those are my jokes. My wife likes my jokes, so I'm glad somebody does. A couple things here before we get started. I wanted to, I've actually been trying to figure out what we're going to do here, and hopefully this YouTube thing is going to work. And and I'm going to try and post maybe 3 videos a week online, and hopefully they'll help. But I just really encourage you guys and me too to try and come up with a schedule just ourselves, because if you guys are up until late in the night, and then you get up, it's noon or 1 in the afternoon, and you're just not going to be as productive in these days. And I'm hoping that just a word of encouragement. I think if you guys could try and get up at a reasonable hour, have some breakfast, do some exercise, and then just set aside time for your different subjects to do studying, I really think this time is going to be more productive. And like I said in that email I sent out this morning, there's big changes with the AP test. It's kind of hard to believe that the test has always been 3.5 hours, and now it's going to be 45 minutes, and you can do it at home, on your phone, on your computer, and it's just free response. But it is what it is, and we're just going to do the best we can with it. We've really almost covered everything that we need to, but when we started the class, I said I just want us to learn a lot of chemistry. So I am going to go over, like, the stuff we're going to do today. I don't think it's going to be on the AP test, but I do want to do some stuff in 15. There is something in chapter 15 that I want to get to later that is going to be on the test. I want to make sure we cover. And then I want to cover just some of the main things in chapter 16 and 17. So we'll just, again, try and really cover chemistry the best we can. And so if you do take chemistry beyond our class, you'll at least have some awareness of these things. But we also try and do a good amount of getting ready for the AP test. We, too, in that Princeton review, I'm still planning on that being due on, I think I said April 22nd. We'll see. AP is going to come up with some review stuff, and so we'll look at that too. So, okay. Missing you guys. Look forward. Hopefully we do get back here in a couple weeks, and that would be really great. But we'll see. We'll see. If not, we're just going to do the best we can. Okay, where we left off was in chapter 15, and we had talked about buffers. And I'm actually, when I send this out, I'm going to send you guys a little 5-minute YouTube video on a chemistry guy doing a little experiment with a buffer, and it just really made the point. And we were in the middle, just kind of starting doing titration problems. So again, knowing that these are not going to be on the AP test, so I'm going to work them, and I'm going to try and go through them that you understand, because these are definitely some pretty good problems. But I'm also probably not going to give it the time that it really needs, but I think it's really some really good chemistry problems. So where we left off, we were talking about, and in the notes, if you look on the notes, I know that we did this page right here, and you can see that, and again, you can look online and see that. And I've written that on the board here too, and we've got the what is called the buffer zone here. This is where we have the components of a buffer with in this case, a weak acid and its conjugate base. So the pH is stable. We have the equivalence point, and we also have the halfway point. And we talked about those things on the titration curve. So I kind of want to refer back to that as we do these problems. So let me go to the next slide. I guess I can't remember exactly. So if you just real quick. So in doing this problem, and again, we might have done this, to be honest with you, I can't remember, it's been now a week and a half, but the first thing I'm going to do is I'm going to write out the equation for what's going on here. And remember, I'm going to take out Na, because Na is a spectator ion, so I'm not going to include that. So I'm going to take the acetic acid, and one thing this didn't say, but you have to be given the Ka value for the acetic acid, which is 1.8 times 10 to the negative fifth, and I think I included it in the next slide, but I'm going to take the acetic acid, so I'm going to write the equation, just the chemical equation for what's going on. I'm going to combine it with hydroxide again. I'm going to take sodium out because it's just going to be a spectator ion, so I'm going to get off water, and I'm going to get off acetate ion. Oops.
Should I zoom in on that?
Yeah, just as long as I can see it. And then I'm going to get everything into moles. So, and here's an ice table. So where we are right now on the titration curve is we're right here. We're not quite to the halfway point, and you'll see that. So I've got, again, I'm going to take the milliliters, get it into liters, and I'm going to multiply by the molarity, so I have 0.0025, and so I'm getting this into moles. And then I'm going to do the same thing for the hydroxide, which is 0.0010. And over here, water I'm not concerned about here. And I'm trying to find the pH. So limiting reactant problems, so this is gone. And so I do my ice table on the left, and on the right I add. And so where I'm at is I'm almost to the halfway point, which is where the concentration of the base and the acid are equal. Not quite. I'm not quite to that point, but I'm almost to that point. So at this point, to solve for the pH, the best thing to do is the Henderson-Hasselbalch equation. So I'm going to use pH is equal to pKa plus the log of the base over the acid. So, and again, the Ka I would have to give you, and it is 1.8 times 10 to the negative fifth. And the log, and remember, this is the base, and this is the acid. And one thing to remember, too, that a lot of times when I do these problems and I mess up, is I forget this really should be the concentration, which is the moles per liter. In this case, if I forgot that, because I'd have the liters on both the denominator or numerator and the denominator, it would cancel out. So if I didn't do that this time, if I forgot, I would be okay. So if I just, again, if I took 0.0010 over 0.0015, and again, technically I should really have the total volume, which would be 0.035 mils, but they would be on both the numerator and the denominator, and they would go away. And if you do the math there, again, this is the best way to do it, it's 4.57. That's the pH. Okay, so if you try that on your calculator. So again, where we are, we're almost to the halfway point. If we added just a little bit more OH, where we got those equal, that would be the halfway point. Okay, so there's problem number one, coming up to the halfway point. Okay, so then here is the next step. Okay, this time I've included the Ka value. So this is going to be, I think, the trickiest step. This is going to be when we are at the equivalence point. Okay, so hopefully you guys can see how I did that. Okay, so I'm going to still do the same process. The equivalence point, and when you guys were learning a little bit of some of the stuff that we're doing now with acids and bases in first year chem, you were taught that the equivalence point, the pH is 7. And usually it is, and it has been in AP Chem for 3/4 of the class, that's what it's been. But now it's going to change. Okay, so we're getting where the pH isn't going to be 7. So again, I'm going to do the same process here that I did in the last problem. I'm going to write out the chemical equation for what's going on. So I've got acetic acid plus hydroxide gives me water and acetate ion. So again, I have the acid and I have its conjugate base. And this time, in conditions, or in B, this time I have 0.0025 moles of this, and I have 0.0025 moles of this. Water I'm not concerned about. Acetate's gone, so, or acetate I'm going to add to, but this time they're both going to run out at the same time. And this goes back to what we learned in the last chapter on the test we took before spring break. So the key here now at this point is that this base is a conjugate base of a weak acid, which means that this base can hydrolyze water. So this only happens at the equivalence point. So we can now go one more step. Where we are on the titration curve is we're at this point. So the moles of acid equal the moles of base. So now to figure out the pH though, because this again is a conjugate base of a weak acid, it can hydrolyze water. So I can now write out another reaction. Again, this only happens at the equivalence point. So I'm going to take that acetate ion and it's going to hydrolyze water again, which means it splits water. And this is 0.0025. Water, again, I'm not concerned about. And here's 0 and 0. Now, this is where we're going to go back to X and what, like we learned in both chapter 13 and 14, that X I'm going to ignore. And then I have X and X. And this X is for OH. And so once I have solved for X, I will have solved for OH. And I could solve for the pH. So let's just stop here. So this is at the equivalence point. At this point, so because I have made some of this base that can hydrolyze water, I need to show it hydrolyzing water because it's a strong enough base to hydrolyze water. And then I need, and now this is acting as a base. So Kb is equal to Kw over Ka. Okay, so I define Kb as Kw over Ka. And so that's going to be x squared. And now this time, I told you in the last problem, this is where I always forget this. But this time, the last time, if I forgot to put the liters in the denominator, it would have been okay. Because in that Henderson-Hasselbalch equation, it was on both the top and the bottom. But not here. I got to remember this time. So I have 0.0025. And the total volume was 50 mils. So I've got 0.0025 divided by 0.050. Okay, I had to remember it this time. If I didn't, I would have been mistaken. So when I solve for X here, what I will have solved for is OH. And if I solve for OH, what I get is 5.3 times 10 to the negative 6. And then to solve for the pH from there, it is 8.72. Okay, and that is the answer to that problem. And again, this is a problem, and you guys have been through 1 3/4 now of chemistry. And every time prior to this that we were at the equivalence point, the pH was 7. But not now. Okay, in this case, we have a weak acid and a strong base. And so you got to ask yourself, does a pH of 8.72 make sense? And you know, if we have a weak acid and a strong base, yeah, that pH makes sense. So again, at the equivalence point now, weak acid, strong base, pH isn't going to be 7, it's going to be greater than 7. The key in that problem is that step where we had to hydrolyze water. So again, that's a good problem. That's always the, again, kind of the more difficult problem. Okay, I want to do one more step here. Okay, so let me go here just real quick. So here's condition C now. Okay, so now C. So now I've added more sodium hydroxide. So if you could follow what I'm doing here, so, and these are hard problems. They're hard chemistry problems, and I think, to me, there's always some kind of fulfillment in doing problems like this, because just to see how it works, I think is kind of fascinating. Same process. So I'm going to write out the chemical reaction for what's going on. So again, it's acetic acid, it's the hydroxide. It's going to give off water and acetic acid. Okay, and the moles that I've got, this time I have every time I always have 0.0025 moles. And again, if I can get this into moles in my ice table, I always do that. I always get it into moles. And same thing here, 0.0035. Water I'm not concerned about, and here. This time, the acetic acid runs out first. So where we're at now is we're now up to this part of the titration curve. So the acetic acid is gone. But what's left over is the OH. And one rule in doing these problems is if you ever have excess OH or H plus or H3O, you're going to find pH from that. If you have excess, if what's left over, what you have more of is hydroxide, hydrogen, hydronium ion, then you're done with the problem. You know everything from there. So if I know the OH, and this is a base too, and it would contribute to a higher pH as well, but not nearly as much as OH. So I'm going to find the concentration of the OH, and again, I got to remember to put on the bottom the volume. And so the volume this time was 60 mils, so I get that into liters. So I have to remember, again, that's something, and the reason I say that is because I've made that mistake so many times myself in doing these problems, to always make sure you get the total, when you're doing the molarity, you get the total volume on the bottom. So there's the OH, and if I know the OH, then I can solve for the pH, and the pH comes out to be 12.22. Okay, so that's, again, that's a series of some really, I think, really good problems that, again, they're not going to be on the AP test, but they are on the quiz that I've given you. And I just wanted you to kind of, not to spend a lot of time, but a little bit of time doing these problems. Okay, so now I'm going to go back to this and just looking at a titration curve. And again, you guys can look at the notes here online, but you can look at comparing a weak acid to a strong acid. And notice, like here it says equivalence point is when all the reactants are consumed, not by the pH of 7. And so that, again, is something that is new here, is that pH isn't always going to be 7 at the equivalence point. It says a strong, number 2, the strong acid of the same molarity as a weak acid starts at a lower point on the titration curve. Why? Because it's a strong acid, so it's going to produce more H+, and the more H+ goes up, the more the pH goes down, and that's why the strong acid starts lower. And then number 3, a weak acid, when titrated, changes pH rapidly at first. I'm just talking about right there in blue. It kind of goes up before it flattens out. Then it slows down. The reason for that is you haven't quite created a buffer yet. The solution hasn't created a buffer yet. And it does it pretty quickly, but that's why that goes up like that. And you can see the difference between a titration curve for a strong acid and a weak acid. Okay, I think that is a good place to go ahead and stop. So let's go ahead and stop for today, and you guys can look at this, and we can pick up more later this week. Missing you guys. Do your studying. Talk to you later. Bye.